Alright guys, so picking back up where we left off, we had started the part that requires the calculator. So number 20 here says the path of a place-kicked football can be modeled by the functions y equals negative 0.0226x times the quantity of x minus 46, where x is the horizontal distance in yards and y is the corresponding height in yards. So the first question they ask is, how far is the football kicked? So what I want to do first is take my equation here and plug it into the calculator. So negative 0.026x times x minus 46. Alright, and then let's go look at the graph. So notice my window here right now is going from negative 10 to 10, negative 10 to 10. If you want to get your window to look like this, hit zoom in option number 6. Takes you back to the standard graph here. So we can see part of our parabola, and if we follow the path it would keep going up and eventually come back down and cross somewhere over here. So we want to see where it crosses, so let's go into window and change it. I'm just going to guess maybe, I don't know, 80, just something bigger than 10. And let's change the y max also, because we could see it continue to rise up above. And let's make the y max, I don't know, 80 as well. And just for fun, we know that in the real world we don't ever go into the negative quadrants. Let's change that to 0. So we'll go from 0 to 80 and 0 to 80. Oh, that 80 thing was too much, but so we can now see the whole parabola shape here. So we're kicking the football, it's going up into the air, and then it's landing. Okay, so we want to find how far it goes. Well, if it starts at 0, 0, and it ends over here at this point, then we need to figure out where's this point. So second trace, option number 2. Second trace, option number 2 is 0. So we're going to move to the left side, which we're already on it. And then move our cursor over to the right side of the 0 as well. Tell it to guess between there. So we can see we have a 0 somewhere between, or somewhere at 46, 0. So apparently the football has been kicked 46 yards. So that would be the answer there. See, I've already written that down over here. My little answer key. 20A is 46. Then we also wanted to figure out what is the football's maximum height. Right here. So we need to figure out how high this goes. That's going to be second trace, and the option there is maximum. So we're going to find the maximum as well. So moving the cursor so it's on the left side of the maximum, which if you want to do a shortcut here, we know that the zeros are between 0 and 46. So the left bound will say 0. The right bound will say is 46. So the guess number between there, and it'll pick up the maximum that's between there. So it appears to be at the point 23, 13.754. And as we know, when we're writing the maximum, you're writing down the y value. So there we'd say 13.754 yards. Okay, easy enough. 21, they give us a table talking about how wind affects a runner's performance in the 200-meter dash. So we want to take out our calculator. We want to put the table into the calculator so we can do stuff with it. So to do that, we're going to go into Stat, which is this button right here. Stat, over and Edit the numbers that are in there. So you can see I was looking at stuff previously. If you want to clear out a whole list of data, just go up and highlight the column here. Hit the Clear button. Clear, hit Enter. It'll take the whole thing out. Clear, Enter. So we want to type in our data that we've got. So the x values start at -6 and go up to 6 by 2's. So -6, -4, -2, 0, 2, 4, 6. And the corresponding y values, notice here that I'm typing the top column into L1 and typing the bottom column into L2. Oops, that's just 0.67. And then -0.57, -1.05, and -1.42. So get it all typed into L1 and L2, then go back to the Stat button again, go over and calculate, and we want to find a quadratic model, which is option number 5, quadratic regression. Hit enter, and it gives it to you. So if you don't have your diagnostics turned on, you probably won't see this r squared here, your correlation coefficient. If you want to turn that on, you'll press second and then catalog and scroll down until you get to diagnostics and turn diagnostics on. And then when you go back and do regression again, you'll have your r squared here, which is good to know. So notice the most important thing here is this e to the negative 4, which means that this number isn't actually negative 4.76, but instead it's negative 0.000476. So when you're writing that down, be really careful that it looks something like this. Alright. So part B here asks us to predict the change in finishing time when the wind speed is 10 meters per second. Okay, so I'm going to do a shortcut here on my calculator. If you can't follow this, that's fine. You're more than welcome to go back and just do this 0.11904 and then type in the x value that you're multiplying by and square it. Okay, so we'd have, it says to predict it at 10 meters per second, so times 10 squared. You need to go back and type in negative 0.0 or 0.30857 times 10 to the first, and then minus 0.000476, and get it that way. So apparently the wind speed there would be negative 1.896, and that is measured in meters per second according to the table. So writing down your units is always important. So notice here they tell you that it's meters per second. Oh, and the change in the finishing time, that was measured in seconds, and that's what we were trying to figure out. So be really careful when you're writing down your units that you write them down correctly. So the change in finishing time when the wind speed is 10 meters per second, apparently that's going to cut off cut off about 1.89 seconds from your finishing time. The wind speed will help you out. Okay. I said I was going to show you a shortcut. Another thing you can do here, if you don't want to type all this stuff in, so you can let the calculator do all the work for you. So you'll go back to Stat, Calculate, and whenever you do the quadratic regression, you're not going to hit Enter right away. You're just going to go to Variables, the vars key, go to Y variables. Oops, I missed. Y variables, Function, and choose Y1. And what that's going to do is it's going to take this quadratic regression, it's going to plug it into Y1 for you. Ta-da! So if we go back to Y1, we'll see that equation's already written in for us. So then what we can do is go and look at the graph. And we want to predict, I'm going to need to change my window to see this. Notice that all of the Y values here, oops, were between -5 and 5, and the X values were between -5 and 5 is -5, and then we're plugging in 10, so this needs to be bigger than 10. Just changing out my window a little bit. Alright. Okay. So we wanted to predict when the wind speed is 10. So if I go to trace, I can just type in the 10 and it'll tell me the Y value that way as well. A little bit less work, or maybe it's more work if you don't know what you're doing. So either way will work though. Either taking your formula and plugging in 10 for all of the X's, or graphing it on the calculator and plugging in 10 that way. Both of them will get you the same answer in the end. Alright, 22. Suppose you throw a frisbee over a 12-foot fence, barely clearing the fence. The frisbee reaches its maximum point directly above the fence and lands 12 feet from the fence. Using the fence as the axis of symmetry, write a quadratic function that models the, I think that should say, the frisbee's height instead of the ball's. Or maybe we're throwing a ball instead of a frisbee, who knows. So what we've got here, let's draw a picture here to help us out with this. Here's our fence. We know that that's 12 foot high. And then here we are over here. Ta-da. And we're throwing the frisbee, I'm guessing from a height of 0. Is what they want us to assume. So we are 12 feet away from the fence and we're throwing it so that it just barely clears it and then lands on the other side. And I'm guessing we're going to assume that we're throwing it from the ground somehow. That's what they want you to see. So we have a point here on the parabola at 0, 12, or y-intercept if you will. We have a point at negative 12, 0. And we have a point at positive 12, 0. Okay. So we want to write a quadratic function that models the ball's height. We can do that. So if this is the maximum, that's also going to be your vertex. So in vertex form, y equals a x minus h quantity squared plus k. The x value here is your h, and the y value is your k. We also know a couple other points on the graph, so if I plug in 12 for x, I will get out 0 for y. And using those bits of information, we can solve for a. So moving the 12 to the other side by subtracting it, a times 12 squared. So negative 12 equals a times 144. Dividing both sides by 144, we see that a would be negative 12 over 144, which is the same thing as negative 1/12. So our formula here would be negative 1/12 x squared, because we've got x minus 0, plus 12. Right? And that would be your equation. Alright, moving on. Number 23 says for the following function, the vertex of the function's graph is given. Determine a and b. So we have y equals ax squared plus bx minus 30, and the vertex they give us is at 4, 2. Okay, so we know that to find the vertex, the x value anyway, is negative b over 2a, and that apparently equals 4. So minus b over 2a is equal to 4. So therefore, negative b would equal 8a. Good to know. That's one equation down. So whenever you have two unknowns, you're going to need two equations to set up and solve for those two unknowns. So there's one of them. We also know that if I take the x value here and I plug it in, that's going to equal 2. So 2 equals a times 4 squared plus b times 4 minus 30. So 2 would equal 16a plus 4b minus 30. So if I add 30 to the other side, 32 would equal 16a plus 4b. And then just to make my numbers a little bit easier to work with, notice that all three of these are divisible by 4. So let's do that. Let's divide by 4. So 4a plus b equals 8. And then take what we got over here. We know that similarly b then would equal negative 8. So I'm going to take what b is equal to and I'm going to plug it in. So then 8 would equal 4a minus 8a. So 8 would be negative 4a. Dividing both sides by negative 4, we get that a is negative 2. Cool to know. So then plugging that back in over here, b would be negative 8 times negative 2, which is 16. Okay, Okay, so we know that A is negative 2, B is 16, and we've solved the problem. That was number 23. Okay. Alright, moving on. 24. Your school is adding a rectangular eating area along part of the side of the school. The eating section will be enclosed by a fence along its 3 open sides. The school has about 120 feet of fencing to put around the new eating area. What are the dimensions that will maximize it? Okay, so we've got our school here. Here's our eating area that we're adding in. We want to figure out what makes this have the biggest area possible. I want to maximize that. So I don't know how long these sides are, but I do know that if it's rectangular that they're the same. And I don't know how long this side is, so I'm going to call it a totally different variable because maybe it's equal to x, maybe it's not. Who knows? Alright? So what I know about this is that if I add up all the sides here, x plus x would be 2x plus y. That can't be more than the amount of fencing that I have, which is 120 feet. And I'm going to assume that if we're trying to maximize the area, they're probably going to use all of the fence. So we'll say equal to rather than less than or equal to. So I'm going to go ahead and solve for y here. Y would be negative 2x plus 120. So this is the equation for my perimeter. Okay. I also want to write an equation for the area. Area of a rectangle is base times height. X times y. And then I want to take what I found for y and plug it in there. So x times negative 2x plus 120. And this gives me an equation that only has x's in it, which is good. So negative 2x squared plus 120x if I distribute the x through. So notice this is a quadratic. It's negative in the front, so it's going to open downward. If it opens downward, it's going to have a maximum at the vertex. Right, so what I want to do is I want to find where does that maximum occur at. So x equals minus b over 2a is how you start finding the vertex. It's how you find the axis of symmetry. In this case, b is 120 and a is negative 2. So 120 over 4 would be 30. So I've now found that the x value here is 30. So this is 30 feet. This is 30 feet. Which means so far we've used up 60 feet of the 120 that we had altogether. Which means that there are 60 left for y to be equal to. Okay. So the question actually asks what are the dimensions that will maximize the area? Well, if it's built to be 30 feet by 60 feet, then we'll have the biggest area possible. Okay, problem solved. All right, so that's another page down. Awesome, almost there. Got a couple more problems here that I'm allowed to use a calculator on, so let's go ahead and work through those. So you are using glass tiles to make a picture frame for a square photograph with sides 10 inches long. You want the frame to form a uniform border around the photograph. You have enough tiles to cover 300 square inches. What is the width of the frame? Okay, let me read this problem again really quickly here. You want the frame to form a uniform border around the photograph. You have enough tiles to cover 300 square inches. What is the width of the frame going to be? Okay, so we have a nice little diagram here to help us with this. So what we know is, from looking at this, well, we know what the area of our tiles are going to be. The area is going to be 300, and we also know that that's equal to, in this case, notice that the base would be x plus 10 plus x, which is 2x plus 10. And we also know that the height is also 2x plus 10, so square. Alright, so 300 equals 2x plus 10 squared. That's one equation. There's only x's in it, so we can solve for x. Let's go ahead and multiply this out. Recall again that squaring something is like multiplying it by itself. So 2x and 2x would be 4x squared. And we get another 20x and 20x, which would be 40x. 10 times 10 is 100. So we have a quadratic here. We want to get this set equal to 0. So I'm going to subtract the 300 from both sides. Minus 200. Notice that all three of these numbers are divisible by 4. So let's divide both sides of our equation by 4. Alright. Let's see. I'm not seeing any factors of 50 that are going to combine to give me 10. So I don't think factoring is going to be the method that I can use here to solve this. However, I can use my calculator, which makes it much, much easier. So what I want to do is I want to go in and graph again. So let's clear out this mess. X squared plus 10x minus 50. So type that in. I'm going to go back and change my window, hit zoom 6, so it goes back to the normal window. Well, I can see one of my values here appears to be at approximately 1, 2, 3.5. So let me zoom out a little bit so I can see where my other one is. Zoom out. Ah, there it is over there. So let's go back and zoom in a little bit more so I can see my axis a little bit clearer. Let's say negative 30 up to 10 and negative 10 to 10. This is really not necessary. It just makes me feel better about myself. So I want to find what are those two x values there. Second trace 0. So I can see one of them appears to be, I don't know, somewhere about negative 20. So let's say the left bound is negative 30 and the right bound is negative 10. Oh, I was way off. It's not negative 20 at all. It's negative 13.66. So one of my x values is negative 13.66. However, to be the length of a side, that doesn't make much sense, right? I can't have this little side length be negative 13.66 inches. So that idea is out. No. What will work though is this positive one here. Second trace 0. We said it was about 3.5, so let's say the left bound of that would be 0, because 0 is on the left side of 3.5. And let's say the right bound is 7, because 7 is on the right side. So this one picks up to be 3.66 inches. Okay. So using our calculator, we find that this little piece here would be 3.66 inches long on our side. So what is the width of the frame? Well, 3.66 times 2, or maybe they just want the 3.66, I don't know. Yeah, I'm assuming that they just want us to find x there, so kind of reinterpreting what I said. I'm going to guess this would be your answer. Okay. Alright, a couple more problems here. The height in feet of a baseball t seconds after it is hit is given by the function right here. What is the maximum height? So we had a problem like this earlier. I'm going to go ahead and graph it. So y equals negative 16x squared plus 96x plus 3. Graph. Let's go ahead and change our window again, zoom 6. See it crossing somewhere around 0, and then it goes way up there. So let's change our window, maybe the y max, let's try 100. See what happens with that. Nope, 100's not big enough either. Closer though. Let's try 200. Alright, so now going up to 200, I can see what the max, or where the maximum is. So let's try to figure out what it is. Maximum left bound, so move your cursor so it's on the left side, then move your cursor over so that it's on the right side. Tell the guess between there. So we get 2.999 or 3 as the x value, and the y value is 147. So how high did it go? 147 feet. Okay, when will the ball hit the ground? Now that would be down here where it crosses the axis. Second trace 0 on the x-intercepts. So be on the left side, about right there is good. Moving it so it's on the right side. And that looks good. Appears to be at 6.031. So 6.031, and that's measured in seconds. Alright, another one bites the dust. So here we have a sign chart given to us. So they noted here that it changes signs between, or at -2, and it changes signs again at 3. Those are your x-intercepts. Notice that between -2 and 3, the graph is positive, so it's above the axis. And that from -2 on, it's negative. And from 3 on, it's also negative. So just making a rough sketch there of what the graph might look like. It's not beautiful. It's not even really much of a quadratic. It's just an idea of what the graph might look like. Where is f of x positive? So they have this function here, f of x. We want to find where it's positive at. So to do that, you need a couple things. The first thing you do is you need to try to factor this down. So we can do that. We have 4 terms here. We're probably going to factor by grouping. So on these two, you can pull out a 3x squared. That'll leave x minus 4. Here, you can pull out a -5, which would leave also x minus 4. So this thing's going to factor as 3x squared minus 5 times x minus 4. Okay, so we know now that one of the zeros occurs at, well, x minus 4 equals 0 would occur at 4. Okay, so that's one down. We also can set this part equal to 0. 3x squared equals 5. So x squared would be 5/3. So then finishing solving, I need some more room over here. If x squared equals 5/3, then we can take the square root of both sides. Equals the square root of 5/3. I don't have an eraser. That's a 3. So x would be plus or minus the square root of 5 over the square root of 3. Which, for the sake of this problem, I think it's okay to leave it just like that. You don't have to rationalize it every single time. Okay, so we have x-intercepts at 4, at root 5 over 3, and at negative root 5 over 3. And the question asked us, where is the function positive at? So this is kind of a question that reaches a little bit. You kind of have to know a little bit about sign charts to be able to answer this. So the easiest way to figure this out is to figure out what is the sign between one of these values. For example, right in the middle of these two would be 0. So if I plug 0 into my function and see if it's positive or negative there, that'll tell me what the sign is in between these two numbers, which is good to know. And then I can use that to figure out what the other signs would be. Alright, so if I plug in 0 here, well, 0 minus 0 minus 0 plus 20, 20 is a positive number. I can see that it's positive between these two values. And I also know that this equation was cubic. It was 3rd degree, and it had 3 zeros. So what's going to happen there is that at each time it goes between them, it's going to change sign. Negative, positive, negative. So it's going to change sign every single time it crosses one of these points. So then the question asks, where is it positive at? Well, it's positive from negative root 5 over root 3 up to positive root 5 over root 3. and also from 4 up to infinity. So we'll see more problems like this in the future. You won't see a question like this on the test. I just thought it was neat to go ahead and start thinking about. We'll talk more about multiplicity and end behavior, things that will make this question much, much easier to solve. But for now, just practicing the factor by grouping is the main thing that I wanted you to see there. So none of this factors is good to see. All right. So for the rest of these problems, I don't think we're going to need the calculator anymore. So I'm going to pause or stop this video and start a part 3 so that it doesn't get super long. So hopefully this has been helpful. All right. If you have a question, feel free to leave a comment below. I'll get back to you. Otherwise, good luck.